So we're asked to determine, write the equations for the ionization equilibria um, corresponding to pKb values of 6 and pKb value of 9.8 for an antimalarial drug, quinine, right? Which is a diprotic base. So we're given a concentration, but let's first do part A. The pKb value of 6 would mean that the Kb value, remember that pKb itself is pKb is the negative log of Kb. So the base dissociation value Kb would have been antilog of minus pKb. So that's 10 to the power of minus 6, which is, 1 times 10 to the power of minus 6. That's a Kb, right? And the pKb2, right, which is 9.8, the Kb would also have been the antilog of that. So 10 to the power of minus 9.8. And this is giving us 1.5 times 10 to the power of minus 10, right? Now, so of course, since you can see that KB1 is greater than KB2, so the first equation that would be useful, that would show for KB1 would be the first time, um, the ionization, so C20, H24, um, O2, N2 plus water. Then these will ionize it will gain only one proton. So you have HC20, H24, O2, N2 plus OH, right? That's what you're going to have. Then the Kb of this, or the pKb of this is 196, right? Or the Kb here is 1 times 10 to the power minus 6. Right? Or the Kb is 10 to the power of minus 6. The second would be the ionization equation for the second one would now be this one ionizing more, receiving another proton, so HC20, H24, um, O2, N2, plus more water. Then it will ionize to give us H2, C20, H24, O2, N2, 2 plus hydroxide ion. Now this is pKb value of 9.8, or the Kb value, uh, or the Kb value, the pKb value is 9.8 of this, or the Kb value is the 1.5 times 10 to the power minus 10. 1.5 times 10 to the power minus 10. So that is it. Now, the second question said we should find the pH of a saturated solution. So we're going to be using the first Kb, right? But we need a concentration of the um, concentration of the quinine. The concentration of the quinine, C20, H24, O2, and 2 would be 1 over your 1,900 mils. So I'm going to convert that to liters now, right? And to mole per liter. This is 1 gram per mil, right? So we want to convert that. We need a mole per liter, right? So we're going to change that to 1 uh, times 1,000, right? Divided by your 324 times the molar mass. Sorry, that's 324 is the molar mass. I'm so sorry. 324 is the molar mass. So 1 gram times liters, right? Divided by 1,900, the volume, multiplied by the molar mass, 324.42. At the end of the day, that concentration, C20H24, O2N2, would be 0.0016 molar. So the pH, we need the Kb expression, right? The Kb expression, which is the first, this one, the ionization of the first one, this first one, right? So 10 to the power of minus 6, 10 to the power of minus 6 equals x squared, which is the concentration of the conjugate acid and the hydroxide ion, divided by 0.0016. So the concentration of hydroxide ion will be the square root of 0.0016 multiplied by 10 to the power of minus 6. Then the concentration of hydroxide ion will be 0.0016 multiplied by 1 exponential minus 6. And the square root of that, we have this to be 4 times 10 to the power of minus 5 molar. The pH of this, the pH of this will be 14 minus the pOH, that's minus log of OH minus, right? And then you will have what? Log of that plus 14. You will have this to be 9.60. That's it, right? It's going to be 9.60. That's going to be the pH of a saturated solution of the uh, of of the quinine, right? I hope that's clear. So basically, we use the Kb of the first one since it is greater to get the answer. Thank you.